The special purpose input-output commands are great, but sometimes they just don't quite do the job. Data files can contain multiple kinds of data, and the load command expects all the data in the file to have the same format. To handle situations like this, Octave provides what are called low-level input-output commands. Before I do an example demonstration, I want to talk a little bit about the Scanf function. This is typical syntax for the Scanf function. The function will accept three arguments: a file identifier, which you get from the fopen command, a string containing formatting information for the data that are being read, and a scalar or array giving the dimensions of the output. This function returns an array of the specified size whose data have the specified format. The format string will start with a % and contain a code for the type of data. For example, %s reads the data as a string and %f reads the data as floating point numbers. The size argument is optional, but if you don't specify it, the output argument will typically be in column format. One important thing to keep in mind is that the Scanf function reads the data across rows in the data file. So it starts by reading the first line from left to right, moves to the second line, reads that one from left to right, and so on. However, the data are written to the output variable in columns. Here's an example of what I mean. Suppose the data shown here are in a file that I want to read from. If I want to read the data as floating point numbers and the file has a file identifier named FID, I can use this syntax. The numbers are read beginning with 1, 2, and 3, and they're placed in the file in that order, but in a single column. The command then reads the second row and places 4, 5, and 6 in the next 3 rows of the output array. Now we're at the end of the file, so the command stops executing. I can specify a size for the output array in this way if I want. In this example, my output array will have 3 rows and an infinite number of columns. Specifying an infinite number corresponds to reading the remainder of the file, since the command stops executing once it reaches the end of the file. When this command is executed, the first row of the data is read, and the numbers are assigned to the output in a column. The output array size is specified to have 3 rows, so this fills all the available spaces in the first column. So the next number that's read, 4, is placed in the first row of the next column. The final numbers, 5 and 6, are placed in the remaining rows in the second column. Now, if we want to make our output array have the same shape as the input data, we need to exchange the rows and columns. We make the first column the first row, and the second column the second row. This is just the process that occurs when we take the transpose of an array. MATLAB's transpose operator is a single quote. So the result of this command, which adds a single quote after the previous command, is this array. It looks like the original set of data in the file. First, let's take a look at some data that's in this rcdata.txt file. The oscilloscope I used to acquire this data puts a 5-line header at the top of each file. The header includes information about the oscilloscope and software version that was used, along with labels for each column of data. I want to read this data into Octave without having to modify or even open the file. So first, I'll close this file, and then I'll read from it with Octave. Since it's going to take a series of commands to read the data, I'm going to create a script file to read the data. It'll be easiest for me to put the script file in the same folder as the data file. That's not absolutely necessary, but it will keep me from having to provide a path to the file I'm reading from. The import functions I'll be using look in the current directory automatically. I'll name the file data read. The first thing I need to do is open the file and get a file identifier. The command is file ID equals fopen of rcdata.txt, comma, rt. close parentheses. The return value is the file identifier, which I've named file ID. The arguments are the file format, rcdata.txt, and the permissions for the file. The R means I want permission to read from the file, and the T denotes that my file is a text file. I only need the T because I'm using a Windows operating system. Many other operating systems don't need that additional information. Next, I need to read the 5 lines of headers. It's easiest to read a single line with the fgetl command. The argument to the line command is the file identifier. So to read the first line, I'll type line 1 equals fgetl of file ID. That'll read the first line of the file and save it as a variable named line 1. I'll use that approach 3 more times to read the first 4 lines. For variety, I'll use the fscanf command to read the 5th header line. The command is labels equals fscanf of file ID, comma, quote, %s, end quote, comma, 6, close parentheses. I send the file identifier to the command along with the type of data. This is a string, so the code is %s, enclosed in single quotes. The last argument is 6, since there are 6 strings that I need to read. Time. fscanf recognizes white space as a separator between strings, and there are spaces between these 6 strings. The fscanf command reads these 6 strings and then stops. If I don't include the 6, the command will keep reading through the end of the file. Now I'll read the data itself using the fscanf function by typing data equals fscanf of file ID, comma, quote, %f, quote, comma, open square bracket, 3, space, inf, close square bracket, and close parentheses. And I'll take a transpose of that with a single quote. The file identifier is, of course, the first argument. %f is for reading floating point numbers. The final argument gives the size of the array that the numbers will be saved in. The array will have 3 rows and potentially an infinite number of columns. Since I don't know how many rows are in the file, this will just let the fscanf function keep reading until it gets to the end of the file. Remember that the fscanf function reads the data in rows but loads the output array in columns. So the 3 columns in the data file get converted to 3 rows of data in the output array. The transpose operator, the single quote, converts the array back to the original 3-column format of the data file itself. I'm done reading the data, so I'll close the file by typing fclose of file ID. This frees up Octave resources that I can put to better use if I no longer need to read data. Finally, I'll save the file and run it by typing the file name, data read. I'll check the contents of the workspace by typing whos. Looks like all the data got loaded, but let's take a look at the data by plotting the 3rd column of data versus time. The command will be plot of data, :1, comma, data of :3, comma, quote, r colon, close quote, close parentheses. The low-level file input-output commands are a little more work than some of the other commands, but they can be worth it. If I have a lot of data files with this same format that I need to process, I can just keep running this same file with different file names. We've built up a variety of capabilities using Octave, and our script files have the potential to become very long. It's easier to work with shorter chunks of code from both a design and a debugging standpoint, so it's typical to break a long program down into several shorter modules. Modules are usually implemented as functions. These functions are identical to Octave's built-in functions, but they're defined by the user. User-defined functions are the subject of the next unit.